Hello friends, it's John Woods, the CTO at the Algorand Foundation. I'm here today to walk you through our paper on consensus incentivization. This is an important change coming to the Algorand network, and we want to get your feedback. We want feedback from everyone, not just folks from an engineering background. So today, I'm going to walk you through some of the main concepts in the paper, and hopefully you'll be able to understand each section, even if you're not working in a technical discipline. So, this paper has been put together by myself, my colleagues at the Algorand Foundation, and colleagues at Algorand Technologies. The purpose of this project is to engineer a native solution at layer 1 in the protocol that rewards the validation of transactions and the new minting of blocks on the Algorand network. We're doing this because we think it's important to increase the decentralization of the network and to encourage individuals to stake their algo, to increase the security of the network. The goals of this paper are to define certain aspects of that design and to inspire discussion around the design. So we're going to look at the economic aspects of the design, source of funds, how we pay out, when we pay out, the technical design, so the types of changes that are required at a protocol level to implement something like this, and we're going to look at mitigations of certain gaming angles that may emerge. When you make changes, especially to decentralized networks, especially where money is involved, you got to be thinking about new threat vectors that can emerge. We want to make sure that the solution is watertight and doesn't leave angles for people to game the system or take advantage of the system in any way. So again, I'm going to make sure this is quite casual. I'm not going to go too deep technically. I want to essentially describe each of the main concepts in the paper, so this won't be a very long video. So in terms of contents, we have some context. We look at the solution design, the incentives that are going to come from the fees on the network. Of course, the fees are a small part of the overall reward at the moment, so we're going to also look at other economic considerations and funds that the Algorand Foundation will contribute to boost the rewards in the short term. We're going to look at the payout function, the frequency with which we pay out, and then some of the mitigations and anti-fragility measures that we think are important. Okay, so for context, folks know Algorand uses pure proof of stake. It's really cool. It's a consensus mechanism that empowers the individual. Why? Because it's really easy computationally to run the VRF, and you can run it on a simple computer in your home. You don't need 200 terabytes of storage, and you don't need a supercomputer to run Algorand's consensus. At the moment, though, folks don't get paid to execute consensus. And so there's some friction there. People still need a computer that's running all the time. They still need to create participation keys if they're going to bother taking their algo and staking it to secure the network. And we want to encourage as many people as possible to do this. We've noticed over time that despite the original thesis of Algorand, which contended that a sufficient mass of folks would come and stake their algo just to secure the network, we're not seeing enough uptake there. And so we'd like to increase the decentralization and security of the network, and we feel by rewarding the block production process, as is done on most cryptocurrencies, we'll see a significant increase in the number of individuals that come along, run a node, and support the network security. So that's the context, and you can take a deeper read there if you'd like. Okay, the solution design. There's going to be a portion of these incentives that come from fees. Those fees, they have to be meaningful in order to see a significant uptick in the number of people that are running nodes. Right now, we have a reasonable volume on the network, but it's not enough to incentivize consensus to a sufficient level. Over time, I believe that with minor modifications to the fee structure and with increased volume naturally as awareness grows and adoption of Algorand grows, because it's just a great platform to build on, those fees will become more meaningful and should be able to sustain the security of the network on their own. In the short term though, short to medium term I should say, and by that I mean over a couple of years, 2 years, 2.5 years, 3 years, the foundation is going to dedicate a portion of funds to boost the number of rewards that are available for node runners. But I'll come back to that later. Just to touch on this part of how we incentivize from the fees. You can read this, the changes that are highlighted here, which are the changes to the code to enable this. But essentially, for all the fees in a given block, we're going to gather them up we're going to scale them by a certain percentage that's configurable. So it could be half the fees, 80% of the fees, 90% of the fees, whatever we need. And that amount will be moved and dispersed to the block proposer. So essentially, if we had it at 100%, all of the fees in the prior block would go to all of the fees in the current block would go to the block proposer of that block. If we had it at 50%, 50% of the fees would go to the block proposer. Now, why do we need this sliding scale? We're thinking in terms of flexibility later on. Maybe, for example, we'll move to a decentralized engineering model like Linux, where there's lots of folks in the open source community who come together to push Algorand forward in years to come. And so the Inc. or to Algorand Technologies may well be part of that, but it would be great to have a decentralized development of the protocol. And we may want to dedicate a portion of the fees to that development or to other community things that come up and matter to folks. So maybe in the short term, we will have that as a high percentage for block rewards, and over time, we may choose to use some of those fees for other purposes. Again, this should all go through the governance process. Now, as I've mentioned in this economics considerations section, we recognize that in the short term, there's just not enough fees to really meaningfully encourage folks to run nodes. And so the foundation is going to contribute a large sum of Algo in a chunk that will pay out over time alongside the fees. And so the block proposer in the short to medium term, whilst we have these two payment sources, the fees and this additional piece by the foundation, the block producer will get the combined value of the fees plus the contribution per block from the Algorand Foundation. Okay, so when you're paying out for the rewarding of consensus or block production on a cryptocurrency, you have to have some kind of function that describes how you pay out. Let's say we start at t equals 0, or like tomorrow. We start at a certain time, and we say, well, how much will be paid out per block to the block producer at a given point in time? We need to have a function that describes that. And so some common ones that you might see, as an example, the simplest one I've seen is Mimblewimble, which is a privacy-focused cryptocurrency. And the last time I looked, it pays out 50 coins per block. So every single block, 50 coins forever and ever. It's a very straightforward linear payout function that does not decrease. That's fine, but I think we've seen across the industry that more nuanced payout functions can yield better results. So, for example, with Bitcoin, it has this step function you might be aware of. It looks like a stairs. So it starts off with 50 coins and then it halves down to 25 coins, pays out 25 for a while, then it halves down to 12 and a half coins, and so on. And so what this has done for Bitcoin is imply deflation. People think Bitcoin's worth more and more year over year because the supply is becoming restricted. So maybe that's something we might want to consider. And then finally, looking again at the industry, I think Monero has an interesting payout function. It also decreases over time, like Bitcoin, quite exponentially, but doesn't do so with a step function like a stairs. Instead, it has kind of a smooth curve that decays down. And unlike Bitcoin, which will go to 0 in terms of rewards, Monero has a tail emission, so it goes down to a certain amount and then trickles at that amount forevermore. So these are the types of things that inspired our thinking around this payout function. In this section, we have some mathematics that describe certain payout functions, and we just put them up for discussion. So we start off with a linear payout function, and this is one that would look like this on a graph. It would start off paying out a lot, and over time it would decrease in a linear fashion, going in a straight line. This first piece here that I'm highlighting, it defines the shape of the line, and this second equation, it describes how much will actually be paid out per block after you normalize the shape for the exact amount of algo that we want to pay out. With the fees, they are dynamic. They go up and down depending on how many fees are paid in a given block. With the Algorand Foundation's contribution towards consensus incentives, we're suggesting that it will be a single block of funds. In this case, we're assuming, say, 200 million algo. We also assume things like a certain block time, 3 seconds. Of course, this will change with dynamic lambda, and we can look at that later on. We think of time as a duration for the payout. So we want to say payout over the course of 3 years as an example. So we want to be supporting this for 3 years, diminishing over time. And then finally, the total number of blocks over which we have to pay out that sum of money over time. And so this normalization factor essentially defines a number of algo that will be paid out on a given block over time between the date we start this, which is going to be in 2024, and the date that the foundation's contributions run out, and how those contributions scale down. So here is a linear proposal, single line. Later on, more mathematics. Again, we have a shape here. This shape is more like a curve. It exponentially decays. And we have the same normalization factor, which we need in order to rationalize the foundation's contributions down to a single block payout. And then we have the final payout function that describes exactly how much will be paid per block. And so we put these, for your consideration. And I feel that both of these are reasonable functions that we might want to implement, and both of them imply deflation, right? They imply an economic increase in the value of algo over time. And so we're assuming that in 2 years' time or 3 years' time, we'll have to pay less algo out because it will be worth more to secure the network to the same standard. Okay. A quick note here, it's worth reading this paragraph, but what I'm essentially saying here is that blockchains have no notion of time. How does a blockchain know what time it is? It doesn't. It's a decentralized network. Some of you might think, well, isn't there a timestamp in the blocks? And there is. And you can use that to roughly gauge what time it is. But that timestamp is not enforced by consensus. And so when the nodes are running the VRF and ensuring that all the transactions are valid in a block, they're not also ensuring that that time is precise. They make sure it's within certain bounds, but they really don't. Granularly ensure that it's correct. And so we're using block time as the round times as a notion of temporal change. Okay, we're thinking, okay, well, 3 blocks have passed. The blocks are about 3 seconds, so 9 seconds of wall time has passed. And this works when you have blocks that are, as they currently are, pretty much on the money, 3.3 seconds all the time. But with dynamic lambda, which is going to be an improvement to the network, where we'll have slightly more dynamic round times or block times, for the improvement that on average, the speed of blocks will be faster. But for the maybe disadvantage from the point of view of consensus incentives, that we no longer have this heartbeat that we can rely on every 3.3 seconds. So we can no longer just say, well, X blocks have passed, 3.3 seconds a block, ergo, X number or Y number of seconds has passed. So what we're suggesting here is that in order to roughly gauge the clock time or the wall time that has passed so that we can correctly pay out the right amount of algo, we will have a mechanism where we assume a certain average and that we can reconfigure that average if we find that we deviate too much from either side of what we expect to be the actual clock time. Interestingly, maybe, in the next section, we're talking about frequency. How often do we pay out? Different currencies have different approaches to this. We're going to pay out on every single block. So you won't have to wait for, say, a week or an epoch to be paid. You'll get paid out on every single block. So it should be quite exciting because folks will get paid out really regularly. And so it'll be fun to see people as they mint their first block and get rewarded for it. Okay. Into the section on kind of gaming mitigations and anti-fragility measures. This section is probably the most technically complex in the paper, so I'll just touch on the core ideas. There are various concerns that we've identified that we think are worth talking about in the paper, just so you know that we've thought about it, and we're thinking about whether or not they need to be mitigated, or whether we can live with them. The first one is absenteeism. Now, maybe I'll just say this. On Algorand, it's pure proof of stake. This means that the VRF selects someone randomly but deterministically from the sea of participants and knocks on the door and says, hey, give me your proposal. Or knocks on the door and says, hey, validate this proposal. This casual description, but you probably get what I mean. And so the concern is, what happens if someone or some entity, company, whatever, some person with a huge amount of stake declares themselves to be online and staking. But when the VRF or the protocol comes knocking on the door and says, "Hey, I'm ready for your block," that person's computer is off and doesn't respond. And so this is built into the mathematical assumptions of Silvio's original paper. 20% of the network can be offline at any given time. 20% of the staked algo that is said that they will be online can be offline and everything's fine. But if more than 20% of the algo that says they're online isn't actually online when the network comes knocking, we could have a stall of the blockchain. Now, of course, this normally is not a problem because 20% of the billions of algo that are staked is a ton of algo. So it doesn't really matter if you're a person with 10,000, 100,000 algo and you're not there when the protocol comes knocking. But if a sufficient glut of people, and these are going to be new people who are coming into consensus incentives for the first time, who are maybe staking for the first time, who haven't got this experience. If a sufficient number of these folks are not there when the network needs them to be, then we could have a stall. So we look at how we might mitigate that, specifically in the context of pooling, because we expect that pools may emerge. Maybe folks won't want to run their own computer at home. Maybe they'll want someone to run it on their behalf. And so you might have someone come along and say, "Hey, I'll run the computer for you. Give me your participation keys and I'll give you back 80% or 90% of your reward. I'll keep 10, 15, 20% as a fee for providing this service." Well, we have to make sure that even in that case, where loads of people's stake is clustered together by maybe someone who has a bad internet connection, who's running a major pool, we got to make sure that that does not stall the network. And so in this section in the mitigation, you can read through it. It's quite sophisticated, but what it basically says is the network will test for this. It will check to see if you're online, and if you're not online or you're not behaving the way we think you should be statistically, so statistically you should be producing a certain number of blocks and you're not doing that, we will, or the network rather, will actively remove you from the staking set and make you pay a little bit of algo to come back online to redeclare yourself to the network. So quite interesting, and we think we have a solution here that will hopefully mitigate this completely. The next consideration is pooling. It's very similar to the previous consideration that I mentioned around absenteeism, and so we have a similar mitigation here, and you can look through this. We think in general pooling is probably healthy. It's probably a natural emergence because, of course, there's going to be a whole bunch of folks who don't want to run computers at home full time. And pooling is fine once it's done in a practical and robust manner. And so we'll work with people who want to learn more about this and give hand-led guidance on it. Finally, there was a concern raised during the discussion of this internally that potentially people would modify the clients. So modify Algorand itself to only do the work of proposing and not do any of the other stuff. And to do it so that they would win the reward and not have to do anything else. Well, looking at this empirically, we just don't think it's a serious concern. The computational burden of executing the VRF and validating contracts is negligible. And ultimately, the work of modifying a client so that you can save a few CPU cycles just isn't practical. But we still wanted to call out that we thought of it and that we were actively considering that as an angle. Finally, I talk about how the foundation is going to contribute a big chunk of Algo towards this incentivization to make sure that it's attractive in the short to medium term and that we get a big and significant chunk of folks coming out to secure the network. Here, we simply say that over time, we may want to consider things like increases to fees or a fee market in order to ensure that the amount of fees that are generated in the long term as volumes increase is significant. But to be clear, Algorand's vision remains unchanged. We're not going to have a costly fee model. You're never going to be paying dollars to send an Algorand transaction. It's always going to be cents, okay? And of course, we will do this in consultation with the community. It's not just our decision to make. It has to be made by all of us because everyone owns this network. but it's here to call out that maybe over time we might want to consider this. And I guess that's it. So in conclusion, we believe that incentivized consensus is the right step. It's going to hopefully decentralize the network and secure it to a level which is higher than today, and hopefully secure it in perpetuity. Okay, and I think that over time, as the distribution of Algo becomes more granular, okay, and you've got more and more accounts that have smaller and smaller chunks, and it's held by less, it's less concentrated in its holdings. We got to make sure that even folks with a small amount of Algo are still, getting out of bed and securing the network with it. And to do that, we have to reward folks, because an individual who's got a few thousand Algo is probably not going to run a computer 24/7 to secure the network unless there's some kind of reward. And I think that that's fair. The work on this, I list the PRs here so that you can go through and you can have a little look at the actual code changes. But barring unforeseen issues, as in softwares, it can be hard, of course, sometimes. But we expect to do production rollout of this by mid-2024. So excited about this. It dovetails really well with all the other changes we're making. From dynamic lambda, which is going to increase the speed of the network even further and make it more efficient in terms of dealing with proposals and the network messages, to consensus incentives, to peer-to-peer, which is going to decentralize the network even further, allowing data to propagate over the network graph from individual to individual, not using relays, and to other things like non-archival relays, which are going to be coming. We have some really great developments in 2024. I hope this makes sense, and I hope this guide has given you maybe an easier time reading through this and certainly grasping the core concepts that we're trying to impart. And as always, here to answer any questions you might have. Happy to discuss it. We want to discuss it. We want your feedback. And JJ and I, who's the lead from the Algorand technology side, he's the head of applied research over there, and he's very bright. He and I will be hosting a Twitter space or an X space where we can take your questions and chat this through with you. Okay, thanks. See ya.